Hello everyone. Ladies and gentlemen, welcome to the Technical Forum of Hydrogen and Fuel Cells Europe. My name is Bernhard Jäckel. I'm the moderator of this stage today and tomorrow part-time. And we present you the newest technologies of the current time. We had a little delay the last years and now the fair is physical finally. And we present today, right now, bipolar plates and gaskets for electrolyzers and fuel cells. And we got the CEO of Eisenhuth, Dr. Thomas Hickmann.
Yeah, hello. Nice to be here again. And it's getting a little bit more crowded. This is also very nice. So, yes. But I just want to step directly into the topic. So I presume you have heard about a lot of things about complete systems, how to operate and so on. But now we get down from the flight highs a little bit lower to the component area. And that's the way where we are going at. And we are not looking at the system any longer, but at the stack. And within the stack, there are several components. And we are looking at everything except the MEA. So the membrane unit is also very important. But then the next thing is the bipolar plate and the gaskets. And that's where we are. Okay, so I just want to give you a small overview of the things we are doing right now and where it is going to. First of all, company, just one slide or two. So we are a typical SME located not very far from here, 1 hour south. We have different business lines. The main business line is is the old industry still, machine building and production of plastic parts. However, this fuel cell business is stepping up with high velocity. Here's a small picture again about our activities. So mold making means molds for rubber, plastic and silicone parts and the production of those. So this is also the basis why we have quite an experience in the gasket and sealing area. So, but now I step into the topic. When we're talking about bipolar plates, there's also kind of a divided world. The metal world, let's say. So these are metal or titanium components on the one hand, and on the other hand we have composite materials. That means conductive, that means graphite or carbon black, and that's the area we are staying at. So not the pure materials, pure metal, but composite materials where the basic is, or one basic is plastic or duromers on the one hand, and on the other hand the graphite and the carbon black materials. And the applications you see already, it's quite different areas since this electrochemical application is a very challenging application. We have electricity, we have temperature, we have acids. So there's a lot of stress on the components, and this means also potential corrosion. But the good thing is graphite is no corrosion topic. So that's the reason why this is now a big topic, especially when the long life or longer life application is the case. And like everywhere in life, we have two sides of a metal. Yeah, the one side, no corrosion, that's good. The not so good side is that metal has better electrical conductivity. So when you have only a little bit space or only a little bit of weight, that means in cars, then the metal fraction is on the way and we are just looking what's going on. But if we step into the trucks and buses, then we have longer lasting applications, and then this is a topic again. So, the way of doing it is, first, before I step into this, You learn this also during your studies. The most important thing is the geometry. Yeah, when I was studying, they told me 70% of the cost are determined by the design. So the geometry is very important. So that's a good thing. We are giving some recommendations. However, most of the players know what they want to have. So it's not our part to make the designs, but to give recommendations how to improve this. And since we have quite some people in the design department, they know also how to do it, and they also can realize this. The next thing is the technology. So, well, I hope you can see it, although the black and blue color is maybe a little bit dark. If I look at the next one, it's getting a little bit better because these are the technologies we have access here in-house. The way of producing these composite materials is different, either by compression molding or by injection molding or by endless production. That means foils, thin ones, or thicker plates. So this is all possible. We have also some trials realized where we can make it back to a roll again, like metal roll, yeah, so you can realize theoretically roll-to-roll process. However, then the electrical conductivity is not so good. In this case, we have to add more plastic material, and then this is, has a negative impact on the technology. Yeah, here's now an example of a bigger plate, the biggest we ever did in injection molding, 660 millimeters length. Yeah, this size, so this is quite challenging, but we could realize it. That means if we can realize this big size, we can also realize smaller sizes as well. Then this is quite new, a very thin application with below 1 millimeter thickness. So it is maximum 1.5, minimum 0.76, maybe 5 millimeters. As endless production where you can then do in process steps afterwards the ready-to-use structure onto it. For the electrolyzers, we exchange the graphite and take in titanium or nickel powders. Same technologies. Here again, this also, but depending on the technology, that means either PEM electrolyzer on the one hand, or alkaline electrolyzer on the other hand. This is the basis where to look at it and see what we can do here. And that means that for a PEM electrolyzer we would use nickel composite plates, and for the alkaline electrolyzer or AEM electrolyzer we would use nickel plates together. And although it is electrical conductivity a little bit less than pure material, to our experience, it is good enough to step into this technology. And why do we do this? Because then we can have access to the other technologies, injection molding, compression molding, endless production. So here we have a cost-effective aspect, which is very positive. And then in this, let's say, very challenging material world, this means we can also replace the expensive materials, like even nickel is exploding, to a certain extent also titanium, by plastic materials. And this, although it is only 20%, but 20% is better than nothing. So this is quite nice. I only have some minutes left. However, the most underestimated component in the fuel cell system is the gasket. So please do have a quite intensive look on this. How to realize it? You can see it here. We also have realized this on several things, such as, well, dispension, injection on metal bipolar plates, injection of graphite plates on the GDL, on the MEMI-A, and so on. Here again, when you look at the left side of the pictures, you see the separate solutions. This is very kind. We here also make only 5 or 10 gaskets in order to get started, to find out, and then you can also evaluate the material, and then you can say, okay, now I want to do the next step. And then we can recommend you how to go there. And for the materials as well, I presume you can also read it afterwards in the streaming. Therefore, I will just say, but we can use silicone, we can use EPDM rubber or fluorine rubber. And so here it is a big opportunity to do the material according to your requirements. And we have access to the material suppliers. And even in these challenging times, it is possible to get the materials from them. So, thank you for your attention. I was told to take 10 minutes. I'm sorry, it is 11 now. So, please, thank you, and please take your questions.
You made it. Congratulations. Are there any questions from the audience? If there's no question right now, have you told them where you can be found?
Yes, we are, as you can see, also on the orange booth area, D29. So it is a little bit, here is B now, so a little bit in this direction. Yeah, so in case of further discussion, I would really appreciate if you come over and join us, and then we can discuss further topics. Thank you very much.
Thanks a lot.